Hey, my name is Chris Miele. I'm a PhD student here at University of Idaho. I'm studying under Dr. Tim Bartholomew, who is a glaciologist. We just went with a little team of 5 people up to Turner Glacier in Alaska. This is a glacier which recently started moving really fast after about a decade of barely moving at all. This is something called glacier surging, and right now we think that glacier surging has to do with what the water is doing beneath the glacier. So we've been setting up a whole bunch of instruments on this glacier, essentially wanting to listen to what's going on beneath the glacier, get an idea of what the water is doing, and seeing if this can help us explain the surging behavior that we're seeing. So it's not necessarily just about surging glaciers, but it's also our way of sort of getting at the bigger question of how does water move beneath glaciers and what is the relative importance of that movement in trying to get a handle on broader glacier dynamics. Up at Turner Glacier, the delivery of meltwater down to the base of the glacier results in this really extreme speed up. And although it's not universally the case that we see a speed up that extreme, it's still the case that glacier dynamics largely do depend on how that meltwater is routed beneath the glacier. So even places like Greenland, which are experiencing in today's changing climate, enhanced meltwater runoff and percolation of that meltwater down through the ice to the bed of the glacier. We expect that the ice is going to be accelerating to some degree in response to that lubrication of the ice bedrock interface. So if we want to get a grasp on how broadly glacier dynamics are going to be changing in response to that warming atmospheric temperature, increased meltwater percolation, this is a really good place to do it.